What is this?
It's my penis.
What is this?
That's also my penis.
You're a lucky man.
What is this? You're still touching my genitals. I'm gonna report you.
I'm not even security.
Hi, I'm Josh King, and don't you wish there was a better way? Well, now there is. Full body scanners are a new piece of technology that remove the need for pat-downs, so you can keep the perverts on the buses where they belong. Airport body scanners are an amazing piece of technology that utilize many physics properties we all learned about in class. Except for you, John Ackersviller, you don't listen in class, but that'll be addressed later, because right now we're talking about body scanners. So, let's dive in. What do body scanners do? Well, there are two different types of body scanners. Backscatter X-ray scanners and millimeter wave scanners. They both use waves to reconstruct a naked body image. Naked? Yeah. Without clothes? So you can see the... Well, no, it's a rough body image, like this. It is just used to detect metallic and non-metallic objects somebody may be concealing on their body. So what physics principles are at work within a body scanner? Well, while millimeter wave scanners and backscatter X-ray scanners both use waves, radio waves and X-rays respectively, they work in the same way. They both emit waves onto the person, which interacts with the matter in three ways. The waves either pass through, are absorbed, or are scattered. The scattered waves are then used to create a computer image, much like in the simplified version using a children's toy. As you can see, when the waves hit the matter and then scatter, they map out an image. While backscatter X-ray scanners produce a two-dimensional image, millimeter wave scanners produce a three-dimensional image. So how did they determine the distance to a person? Well, let's do a calculation, because calculations are fun and they're in the rubric.
Okay, so if we shine a single radio wave onto an object at a frequency of 240 million hertz, how far away is the object if the wave is reflected directly back in half a wavelength? This example is extremely simplified from what the computers calculate. So since radio waves are a kind of electromagnetic wave, they travel at the speed of light, or 299,792,458 meters per second. We also know that the wavelength is equal to the speed divided by the frequency. This means that the wavelength is approximately 1.25 meters long. Since we know the wave traveled a total of 1/2 of its wavelength, if we multiply this by the distance of a wavelength, we'll get the total distance traveled by the wave, which works out to be approximately 0.62 meters long. If we take this distance and divide it by 2, since we know if 1/2 wavelength is to the object and back, a quarter wavelength must be to the object. So we divide the total distance by 2, we get approximately 0.31 meters. So that is how far away the object is from the source of the wave. Although the wave was directly reflected back in this example, where in real life it would be scattered, a computer would do many of these same calculations to get many distances to map out the image of the person. So just to recap, this technology is applicable to our course as it draws from what we've learned about waves and how they interact with matter. Now let's take a look at some of the pros and cons associated with body scanners. One positive aspect of full body scanners with respect to science is that the use of body scanners allows for the further development of better technology and discovery in the science field of waves. One negative aspect of body scanners with respect to science is that since private corporations sell the body scanners, purchasing them gives the money to rich CEO capitalists instead of reinvesting it into more scientific research and development. One positive aspect that affects society is that these airport scanners make it harder to smuggle things onto airplanes. This improves air transportation safety and can reduce drug trafficking. Also, body scanners are much less intrusive than pat-downs. Ugh. Also, since everybody is scanned, it reduces the need for profiling. Finally, body scanners can reduce the need for airport security of humans, and so the government can save money with the reduced employment. One negative aspect with reference to society is that there have been many health concerns expressed about using waves. That being said, most body scanners pose less of a risk of causing cancer than natural radiation. In Canada, we only have millimeter wave scanners, which are much safer, so you're not likely to turn into a character from The Fault in Our Stars. Another con is that there have been a lot of concerns revolved around privacy and the provocative images produced.
Bruh, look at this dude. Not exactly a picture out of Penthouse magazine.
Another negative impact on society is the reliance on technology. Our technology is advanced, but these scanners cannot detect anything in body cavities. So if you really want to smuggle drugs, put them in your bum.
For example, how to smuggle a ping pong ball. How to smuggle the Blu-ray version of The Sitter with Jonah Hill. How to smuggle the popular Star Wars trilogy. How to smuggle a globe. How to smuggle an entire flute case. Oh, shiega. Watch this. While full body scanners do not directly impact the environment positively, there are many negative impacts. One of these is that the building of these machines results in a lot of carbon dioxide emissions into the environment as a byproduct. Secondly, when the machines reach the end of their life, much of the metal involved in the machine becomes scrap metal. Finally, the machines emit wave radiation into the general environment, which can have supplementary negative environmental impacts. Okay, so let's get down to the money. Look at all those coins. What are you, Jewish? Hey, okay, yeah, actually I am, but that's besides the point. Bet you want to become an accountant, you're so Jewish. Okay, you know what, well, actually that's pretty accurate at my life plan. So, let's get back on topic. The private corporations that build these machines mainly fund the research and development of full-body scanners. The governments of various countries also complete supplementary research into the safety of these machines. The cost of one of these machines, not including maintenance or the preliminary research, is a whopping $150,000. That's a lot of coins. Now I'm not a mind reader. Yeah, you're a Jewish.
Okay, I think everybody's had enough of that. Thanks. So, I'm not a mind reader, but the future developments of body scanners could include scanners that emit lower frequency waves so that they cause less damage to humans, and scanners that can detect objects in body crevices. Also, software is currently being designed to self-monitor the scans to check for potential threats, as opposed to having humans watch over the computer screen. In addition, this area could be improved by being able to better detect low-density objects, because the current waves have difficulty reflecting off of objects of low density.
For example, imagine I'm a wave, and that wall is of low density.
Finally, full-body scanners could be improved by using less expensive and more biodegradable materials, thereby making them more cost-effective and eco-friendly.
And who knows more about being cost-effective than the Jews? Yeah, they get it. I'm Jewish.
So in conclusion, airport body scanners are amazing and complex pieces of technology that relate to the physics concepts taught in our course. While there are many positive and negative aspects of these machines, this area could be greatly improved to reduce these negative impacts and allow for better security, cost efficiency, and environmental effect. Now I'm running out of time, so it's extremely important that I tell you